Hello guys, welcome back to Edexcel Science channel. And now we are at question 21 from 2026 June IAL Chemistry Unit 2 paper from Edexcel. Describe how four different organic compounds can be produced by reacting 2-bromobutane with um, 2-bromobutane with potassium hydroxide under different conditions. Refer to the types of reaction, the different types of isomerism that occurs, and detailed explanation of reaction mechanisms and practical procedures are not required. So this is a classic question from our organic chemistry in chemistry unit 2. So let me use a flow chart to explain this better. Okay, so look at this flow chart over here. This question is about a halogenoalkane reacting with alkali under different conditions. In our syllabus, we have two conditions, okay? So let's say you have any kind of halogenoalkane and you want to react with potassium hydroxide or sodium hydroxide, any kind of alkali. You can react them in two different ways. One of them is in aqueous solution. So basically in presence of water. If a halogenoalkane reacts with an alkali in an aqueous medium, you will get alcohol, okay? And it will go through a nucleophilic substitution reaction. But on the other hand, if you look at B, if a halogenoalkane reacts with alkali in an alcoholic or an ethanoic medium, then you will get an alkene. And this process is an elimination reaction. This process is a nucleophilic substitution reaction. So in this question, the alcohol is one of the product, right? The alkene has carbon-carbon double bond. So that means this gives EZ isomerism, geometric isomerism. So from here, we will get the other three products. In total, we will have four products. So let's see how this happens. So you have 2-bromobutane. So meth, eth, prop, but, at 2-bromo. So on the carbon number 2, I will have a bromine. Okay, I will skip all the hydrogens, but let me still just draw the bonds. Okay, so if you are reacting 2-bromobutane with potassium hydroxide in aqueous solution, what you are going to get is this bromine is going to get substituted by an OH, forming an alcohol. So this is one of your product, and this is butane 2-ol, okay? Because on the second carbon, we have a alcohol functional group. But if I take the same product, right? Actually, no, same reactant, which is 2-bromobutane, okay? So let me remove this and let me put a bromine. So if you are now reacting halogenoalkane with alkali in presence of alcohol, it's not going to give you alcohol. It's going to give you an alkene. And the way the alkene is produced is like this. So you can choose bromine and a neighboring hydrogen. Okay. So this is one possibility. And another possibility is, let's say, this one. Okay. Bromine and the other neighboring hydrogen. So let's consider the green one first. Okay. So let's say that this part gets eliminated. So you will have these two bonds disappear and you will have a carbon-carbon double bond over here. But this does not have EZ isomerism. This will not give birth to EZ isomerism. Why? Because one of the double bonded carbon has the same group on it. Even though it has restricted rotation due to the carbon-carbon double bond, but it will still not give you Ez isomerism because of this two hydrogen. So this is my second product. Now, if you take the same thing, right, the same reactant, and let's say that this part is now eliminated. Okay, this bromine and hydrogen is eliminated. So I will remove this. I will remove these sigma bonds, and there will be a carbon-carbon double bond over here. Now, if you check it out, right, if you look at this double bonded carbon, it has a hydrogen over here and a methyl group over here. This double bonded carbon also has a hydrogen over here and a methyl group over here. That means both of the double bonded carbon has two distinct or different group on them. So we have restricted rotation, we have different groups on the double bonded carbon. So this will give me Ez geometric isomerism. So this is product number 3, and its other isomer will be my product number 4. Okay, so if I draw this in a better way, so okay, drawing this would be a little bit difficult in its structural formula. So let me use a skeletal diagram. So this one is basically 1, 2, 3, 4, and this is a double bond, right? And as you can see, the high priority groups are on the other, on opposite sides, right? So it is my E isomer, which is product number 3. And to find my fourth product, all I have to do is 1, 2, 3, 4, right? But I will just give it like this, okay? And this is my double bond. So as you can see, now the high priority groups, which are the methyl groups, is on the same side. So it is my Z isomer. So these are my 4 products from this reaction, okay? That was a huge explanation. Now let's write the answer, okay? Finally. So now I'm just going to summarize everything, okay? My first point is that 2-bromobutane reacts by both nucleophilic substitution and elimination. Okay, I'm just using short form, maybe because I'm lazy. Now you have to mention where does each one take place. Okay, nucleophilic substitution occurs in aqueous solution of potassium hydroxide. Okay, and it produces butane 2-ol. Okay, so this is my product number 1, which is this one, butane 2-ol. Okay, now you have to mention where does elimination take place. Elimination occurs in alcoholic medium. Okay, and um, alcoholic medium and alkene with geometric isomerism is formed. Okay, then you have to mention the products. So the first one that we can see, which is the second product, is basically but1-ene, right? Because the first carbon has a double bond. So but1-ene is formed. Then you have to mention the other product, which has the Ez isomerism. So but2-ene is also formed, with E butene and Z butene. Okay, and that is your answer. I have mentioned the conditions that I require, which is the aqueous solution and the alcoholic medium. I have also mentioned the type of reaction, which is nucleophilic substitution and elimination. And I have also mentioned all the products, 1, 2, 3, and 4. Okay, and that is how we answer this question. If you have memorized all the reactions and the conditions in organic chemistry, this should not be difficult for you to answer. I hope that it was clear. That is it for this video. I'll see you in the next one.